Hey everybody, Mr. Bells here for Precalc A. This is a video for Chapter 2, Section 1, and it's on polynomials and polynomial functions, a little bit of quadratic stuff. Hoping to go through it pretty good pace right now. So again, you guys know you can always pause the video. Remember, I'm going to try and get to everything I can in class, but this is a resource for you if you don't make it to class or if you just need a little review on some things. Occasionally there will be stuff on these videos that, like I said, we're not going to be able to get to in class, so you really do need to be able to watch through it. If you need to take a break and come back to it, please do that too. Okay, there we go. So we're going to start off with exactly what the heck a polynomial is. So polynomial is any combination through addition or subtraction of a variable raised to a non-negative integer power. So like x squared and x, or even nothing. Technically this would be like a minus 5x where the x is to the 0 power. What are things that are not polynomials? Like this, 3 to the x power. This is an exponential expression. Or like this, if it's a negative exponent. So if the variable's upstairs, no good. If the variable's negative, no good. So again, that's what we're looking for here. So how do I figure out a line given 2 points? That's one of the things that we're going to do. Kind of a 2-point summary for a line, but legitimately there's only 2 points that we need anyways for any line. So just a quick little refresher again for you guys on this. 4, negative 6, and let's go 10 and 2. And I'm trying to find an equation for this line. I would get in the habit, if I were you, of trying to sketch some of these things out. So 1, 2, 3, 4, negative 6, that's like down in here, and 10 and 2, that's like in there. So when I sketch this out, I know that I'm going to have a positive slope. It should be close to 1, and the y-intercept should be pretty negative down here. Okay, so those are kind of my quick little things. So how do I get it? It's y minus y, so 2 minus negative 6 is 8 over 10 minus 4. 10 minus 4 is 6. So 8/6 or 4/3, whichever way I want to be able to write that. Therefore, I can then write y equals 4/3 x plus some y-intercept b. And then I can plug either one of these two things in. I'm going to use this one. 2 is equal to 4/3 times 10 plus b, that's 40 thirds, so I need to subtract 40 thirds to find my b. So if I take my handy dandy little calculator here, and I go 2 minus 40 thirds, I get a negative 11.3 repeating. So my equation is y equals 4/3 x minus 11.3 repeating. That makes sense based on my picture over here. Feel pretty good about that. Know that 4/3 is also 1.3 repeating. I'll give you a quick little refresher again on your calculator. You can also do it this way if it is a calculator version of the test. Stat, calc, linear regression is where we get those things, but we got to make sure we put the data in first. So how do I get the data in? I hit stat, hit edit, and this is where it goes. It goes into L1 and L2. So 4 and 10 are my two x values, like this. Negative 6 and 2 are my corresponding y values for my x's. So L1 is considered like the x, L2 is considered like the y. Why aren't they labeled an x and y? Well, lots of times, especially like in a stats class, we might have 4 or 5 variables that are all related to each other, and none of them would be considered x or y. We might consider them different things. So they just use lists to represent multiple variables. So now to get the equation, I hit stat, I hit calc, I hit number 4, linear regression. Number here is where I can store the equation if I wanted to. I go down to there. Again, this is your option. You can hit bars button right here, bars, and then right arrow over the y bars, and then number 1 function. And then you can pick which one you want it to go into. It doesn't really matter. I'll go ahead and pick y1, and then I hit calculate. And you can see my 4/3 slope and that 1.3 repeating. and my negative 11.3 repeating shows up right there. R value, of course, is 1 because you can't have an R value that's less than 1 when you only have 2 points for a line. You can if it was for something else. Okay. So that's one of the things that we'll do with it. Next one we're going to talk about right now is transformations of x squared. And we talked a little bit about this in section 1-6, just kind of a reminder again. This plus 3 right here is a vertical translation. Vertical translation up 3. This right here is a horizontal, the -6 horizontal translation. And that's right opposite of what the number is. If that's a -6, it's going to go +6, right? 6. And this right here, this 1/4 is on the outside. So I'm going to deal with 1/4, and I'm going to deal with the negative. Okay, so the negative flips it over a horizontal line, flips it over a horizontal line. So if you want to say that, kind of like the x-axis, but it won't necessarily be the x-axis because of these translations and stuff, but flips it over a horizontal line. The 1/4, because it's outside, that's considered a vertical shrink. But again, we said that I just prefer that if you call it wide, that'd be really good. Okay. We know that if the vertex, because of this translation right here, the vertex for this one is equal to 6, 3. And that means that the axis of symmetry, which splits this thing into 2 equal parts, is at x equals 6. Again, because it's a parabola, looks like this. Here, let me do a quick little sketch. So 6, 3, it's right there, opens down, and it's wide like this. Axis of symmetry is that line right there. Okay, so how do I get, because this is a nice, it's what we call vertex form, nice vertex form. This one right here is not in vertex form and doesn't necessarily show you the nice stuff. How do we convert it to that? So there's a couple different things that I'm going to show you right now. I'm going to show you something different on number 4 than I am on number 5. So our first start is this. I really want to write it as x squared, x, and then constant. Good deal. So you guys know that this opens up, right? This opens up, and it's pretty skinny because that 3 makes it grow faster. Okay, so I want a vertex. Well, I can find the vertex, or at least the x value of the vertex, by taking negative b over 2a and then plugging that into the equation to find out the other part. So negative b, so that's negative 1 over 2 times a, 2 times 3 is 6. So the x coordinate is negative 1/6. Okay, then the y coordinate is whatever I get when I plug negative 1/6 into this thing. So let's go ahead and go here on my calculator, because this isn't a nice number, and you know, maybe the numbers that I give you on the test will be nicer than that. So I do negative 1/6, and I'm going to store that in x, and then I'm going to type in 3x squared plus 2x, and then minus 8. Good deal. And I get negative 8.25. Negative 8.25. Okay, so that's what I get for it, negative 1/6 and negative 8.25. And let's check and see if this actually gives me what I thought it was going to give me. So I'm going to go here and go to my y equals 3x squared plus 2x minus 8. And I'm going to graph this. So zoom 6 it. Oop, look, right there. That's the vertex. Second trace, I want a minimum, number 3, negative 4, it gets me on the left side of it, and positive 4 gets me on the right side of it. And I hit that, and I can see there I get negative 1/3 and negative 8.3 repeating. Is that what I got? No, that's not what I got. Oh my gosh. I hope some of you were at least saying in the video, Mr. Bells, what the heck are you doing? Negative b over 2a, negative b, that's a negative 2, which means I'm now inputting, well, negative 2, 6, so there's my negative 1/3. That makes more sense. And now I'm going to go back to here, my home screen, and I'm going to do negative 1/3, store it in x, enter, and then just go up and find that expression again, and hit that and hit enter. And now I got negative 8.3 repeating, and that is what really we should have. That was sloppy. Don't be sloppy on that. So negative b over 2a, the b was definitely 2. I should have done a negative 2 over 2 times the a being 3. And now we get that, okay? And I'm going to show you how to do this. I just did it using negative b over 2a and plugging it in, right? And then substituting it in. And then we can also do this, convert this to this vertex form to find out the vertex by using the process of completing the square. And we're going to use completing the square differently than what we did earlier. So now I'm going to write it like this: y equals x squared minus 6x. I'm just going to move that plus 4 over a little bit, like that. Half of negative 6 is negative 3. Put it in my little box, like that. Good deal. And then square it, so that's plus 9. Now, because I'm doing this on the same side of the equation, right? Normally I do plus 9 here and I do plus 9 over here, but I'm going to do it on the same side. I have to do minus 9 on the same side to cancel that plus 9 out. Now you can see I get this y equals parentheses x minus 3 squared, because that's what that factors into, because I just completed the square. And then I get minus 5. So from this one, I get a vertex of 3 comma negative 5 from that original equation. Now, again, that's converting it into vertex form. Let me check on our negative b over 2a. Negative b over 2a. See if the algebra works the same as what completing the square did. So negative b, so negative negative 6. I'm going to go a little slower this time, right? Negative 6 is 6 over 2 times a. 2 times 1 is 2. 6 divided by 2 is 3. Look at that. And that's what I got. I got a 3. Now I take 3 and I plug it into this equation. 3 squared is 9. 9 minus 18 is negative 9. Negative 9 plus 4 is negative 5. And check mark, I'm able to now find the vertex, hopefully 2 ways here, 3 ways if you count just graphing and using the minimum. So you can do it using completing the square and converting it to a nice vertex form. You can use the negative b over 2a and then plug that in to be able to find the y value, or you can use the graphing calculator. And I want you to kind of know all 3, depending if it's a tech or a non-tech situation. And the more we do this, the more this is going to help us in many, many other forms of stuff. So we're going to try and stay with that. Okay. So now we're down to here. We're down to number 6. We're trying to find an equation of a parabola. Let me focus that up a little bit. Given a vertex of negative 3, 4, you know that the vertex is also the same thing as a critical point. So just a summary here on this stuff. So I'm going to do 2 things. I'm going to do a 2-point summary, and I'm going to do a quadratic regression. We're going to try and get the exact same equation out of both. Okay? So vertex at negative 3, 4, and a random point on it at 4, 16. So here we go, 2-point summary. So I know my 2-point summary looks like this: y equals kx squared. I then use my critical point, and I write y minus 4 is equal to k times x plus 3, because it's minus a negative 3, so that's plus 3 squared, just like that. And then I use my point, 16, 4, so I get 16 minus 4 equals k times 4 plus 3 squared. 16 minus 4 is 12, equals 4 plus 3 is 7, 7 squared is 49, so 49k. And now I get y equals, when I divide by 49, And that's a scary looking fraction, but guess what? We can leave it as a scary looking fraction. 12/49, right? Times x plus 3 quantities squared. And then this minus 4 that was over there on that side, when I rewrite it, I got to move it to this side to get it just the y by itself. That will be a plus 4 when I move it over. So this is the equation of a parabola that goes through those 2 points, okay? So now I'm going to show you how to do that with a quadratic regression. So here we go, stat, edit, I'm going to put those 2 points in, -3, 4. So I got -3 and 4 for my 2 x values, and then 4 and 16 for my 2 y values. Reminder again, x, y, not x, y. It's crossed horizontally. Okay, so if I do here stat and calc and quadratic regression number 5 and enter, look at that. It tells me I can't do that. And hopefully this makes sense why I can't do it with just 2 points, okay? Because if I had 2 random points here, let's make them not so random, I'll put them here. So -3 and 4, this one right here, and 4 and 16, this one like right up here, let's just pretend. Do you agree that I could get a parabola that looks like this? And I could get a parabola that looks like this? And I could get a parabola that looks like this? There's an infinite number of parabolas that go through 2 points, okay? So if I ask the calculator to find that equation, it's saying, hey, I can't do that. I need a 3rd point. So this is where common sense has to come into play. If this is my vertex and this is 1 point on the graph, then the parabola has to open up like that, right? Now, if I go directly over and up to this point, I have to be able to go directly over and up to some other point in this area because it has to have symmetry. So what point is that? Well, how far did I go left or right? So I went from -3 to 4, so I went over 7. So if I go 7 this way from -3, I know that I have another point at -10, and I know that I went up from a height of 4 to a height of 16, so I went up 12. So I got to go up 12 again, but this is pretty easy. The y values don't change, so the y value has to be 16. So now I can do -10, 16 as my 3rd point. So stat, edit, -10, enter, and 16, enter. Now I have my 3 points, stat, calc, number 5, quadratic regression, calculate, and I get this. Oops, sorry, lights just went off in the room. There we go. I get this, 0.24489. What the bleep? That looks scary, right? 0.24489. Remember that, 0.24489. Okay, so home screen. What do we have? 12. We had 12/49ths, right? 12 divided by 49 is, it is the same number. Okay, so we're going to try this. Let's see if this is kind of scary, right? Okay, so here's my vertex form right here. I know it's written in red underneath that stuff, but you guys have it down on your paper. 12/49ths, parentheses, x plus 3, parentheses, squared plus 4. Again, a nice vertex form. Now, I need to get that big scary equation I just did for a quadratic regression right there. Okay? So, remember, I can do stat, calc, number 5, quadratic regression, and I just have to go to store regression equation. Remember, on the old calculators, you just do it at the end of your first line. Vars, y vars, function. Now, here's where I got to be smart about it. I don't want to put it in y1. I just wrote the other one in y1. I want to put it in y3, number 3. Calculate. Poof, there's my thing. And if I look at y equals, you can see those are my 2 different things. Okay, remember my first one's in blue, my second one's in black. Zoom 6, there's my blue one. And you can see they are identical. There's my black one. Both ways work. So again, I'm showing you a non-calc way to be able to get an equation of a parabola given 2 points, and I'm giving you a calc way to be able to show how to get an equation of a parabola with 2 points. Please know both of them. Okay, so now we're here. You know, as we go more and more in this class, I want you to be able to do some algebra stuff. So it says a 15 by 20 foot room needs a rug. If the rug is 100 square feet and they want to leave a uniform border around the rug, what will the width of the border be? So we're assuming right now that the dimensions of the rug are movable. So we're going to get a 100 square foot rug. It could be a 10 by 10. It could be an 8 by 12 and a half. It could be any of those dimensions that'll get us to 100 square feet. Okay. So first rule of business when you have something like this is draw a picture, put down the information that you know. So it's a 15 by 20 room. So let's go ahead and do that, 15 by 20 room. And then you're going to put a rug in it. That's 100 square feet. So something, and they want to leave a uniform border. That's important. So let's say that this is 100 square feet. And the uniform border means that this distance and this distance and this distance and this distances are all the same. And we don't know what it is, so we use an X, right? Sweet. So it says, what's the width of the border? Well, let's see some things here, see what we can do. So we know that 100 plus 2x, right? That's this. Nope, can't do 100. Can't do 100 there, because that's not that. We don't know what that distance is. So maybe we try this. Maybe we go, okay, well, what's the area of all of these things? Well, we know that the area of the whole thing is, area of the whole thing is 15 by 20, right? And maybe we know that the area, how do we represent that? I know it's there. How can I represent some of the other things? Well, I know that's 100 plus, what's the area of this stuff right here? Well, this is a rectangle that's 20 by x, right? So I could do that. That'd be that one. This one right here is a rectangle that's 20 by x. Good deal. And then I need to know what this one is. Well, that's a rectangle that happens to be, this is x, and this part is 15 minus 2x. So I could say it's a 15 minus 2x times x, and then plus another 15 minus 2x times x. And I could represent those things. And I could just try a bunch of different stuff with these. So know that it's okay that sometimes when you're going through this stuff, you're just writing stuff down. And let's see if this makes sense, right? So 20x is this one. 20x is this one. And then this had to be, this length right here is 15 minus 2x. So 15 minus 2x times x plus 15 minus 2x times x, both of those two things, plus 100, which was in the middle, has to equal the total thing. So I should be able to add all this stuff together and go. Let's see what we get out of this. Y equals, because again, I don't want to do that by hand. That looks really scary. Okay, so I got 20x plus 20x plus 15 minus 2x times x plus 15 minus 2x. Oop, forgot to insert a parentheses. Insert that parentheses. 15 minus 2x times x plus 100. And then this is supposed to be 15 by 20. Is that good? So I take those things and I do that. I know that this top equation is definitely a parabola, right? Big scary looking parabola. And that's a horizontal line at 15 by 20. So on my window, I'm going to say, I don't think my x, again, this x is going to be probably pretty small. So I could probably be comfortable in going like 0 to 5. I think I can do that. But my y, I needed to go up to 15 by 20, I believe is 300. So if I go up to 400, that should be okay. So there's my thing, and look at that, there's an intersection point. I don't see the whole parabola, and that's okay. I don't need to. I just needed to find that intersection point. Second trace, number 5, intersection, enter, enter, enter. And you can see that I can make the uniform border 3.596. 3.596 feet. And but then I take a little break, and I'm like, man, that looks like that curve's going back down again. So maybe there's something way over here. Let's do x is 40. There was another one over there. Oh, so I should probably find out what that one is. So second trace, number 5, intersection. Move my cursor closer to that point, like this. Enter, enter, enter. And I get another one at 13.9. And I write that down because that's another. No, I don't, right? 13.96 matches, works for all this algebra, 100%. But it doesn't work for that uniform border, because if that was 13.96 and that was 13.96, we're almost already at 28 feet here, and that doesn't make any sense because it can only be 15 foot wide. So this one is what you'll learn is called an extraneous, another example of something we call an extraneous solution, or a, for us, it's non-relevant. So it's a solution we get from the problem, but it doesn't really work for the reality of our problem. Is that good? Hopefully this was good. This is section 2-1. I appreciate you guys watching these videos. For some of you, I'm hoping this has been very helpful to you. Please keep taking good notes on this stuff. Stay on top of it. Practice the problems. Don't wait till Sunday night. Again, this is Mr. Bells. We will talk to you later.